Hello and welcome. In this video, we will see how to do PLC to PLC communication in the TI portal. Now, let's say if we want to do a data exchange between two or more Siemens PLC, then what instructions we have to use, what settings we require. Let us see one by one. So here, what we will do, we will use two CPU, one 1500 series PLC and one 1200 series PLC. So now let us add one 1200 series CPU. So here, okay, so we have to disable this protection. Only legacy communication we will be using it here. Access control disable. Next and finish. We have to ensure the IP address for both the CPU. So here one is ready. So another CPU 1500 we will insert. So 1500. So we have to ensure that both the CPU it should be in the same network. Legacy communication is on. Access control is off. Okay, so here IP address is 192.168.0.1. So we have to make it 2. So both the CPUs are in the same network. Okay, so if we want to do a data exchange, then both the CPU it should be in the same network. So we have to make sure that both the CPUs or the CPUs which we are using for data exchange, all the CPUs it should be in the same network. So now it is in the same network. So now here we will be using get and put instruction. So before using that instructions, we have to make sure that the respective get and put access for the both the CPU we have to make enable. So how to do that? Right click on the CPU, go to the protection and security. In the connection mechanism here, permit access with get and put communication for the remote partner. So here for 1500 it is enabled. So for 1200 let us see. Right click on the CPU, go to the properties, go to the protection and security, and here for connection mechanism, so this get and put communication it is disabled. So how to enable this get and put communication in the 1200? Basically it is we have to do this particular setting for the 1200 CPU. So in the project tree we have to go to the security, user and role. So here in the row, in the users, we have to enable this anonymous user. At the moment it is disabled, and in the roles we have to add get put access. Again we have to come to the users and we have to see whether that get and put access is available. So we have to make it enable. At the same time, PLC administrator it is also we have to make it enable. Now close it and let us see. So this permit access with get and put communication it is available. So make it on for 1200. So this kind of this user role and security setting we have to do it only for 1200 series CPU. We don't require this setting for 1500 series CPU. Now close it. Now both the CPU are ready for data exchange. Now for the data exchange, what data we required? So we will create that data. So we will generate one DB, we will give the name send DB. So here we will be sending some data to the 1500 PLC from the 1200. So in the 1200 series PLC we will add some data. So we will add some bool, we will add 4 bool, 4 real value. So here and some integer value. So for the data sharing, almost all these data types are used. So 4 bool, 4 real and 4 integer. So at the same time we have to disable this optimized block address, so that here it will be required to enter in the instruction. So here 24 bytes we required. So 24 bytes means for the last 4 integer it is having 24 bytes. So now let us come to the receiving PLC. So in the receiving PLC, same data structure we required. So here we will add one DB. So we give name receive and same data structure we required. So here what we will do, we will simply do copy from the send and we will paste it in the receiving. So here 4 bool, 4 real and 4 integer, and at the same time we will disable the optimized block address. So memory area, it is same for send and receive. So now let us use the required instructions. So in the instruction tab under communication section, under S7 communication, there are two instructions, get instruction and put instruction. If we want to write data on remote CPU, then we have to use put instruction, and if we want to read the data from remote CPU, then we have to use get instruction. So as we are sending the data from 1200 PLC, here we will be using put instruction. Give the data block name, so let us keep it by default one. So here in the configuration tab, so this is the local PLC and here we have to select the remote PLC. So here remote PLC is PLC2, that is 1500 series PLC. So here let's consider that if we are using 200 series PLC, then we have to select unspecified CPU and we have to enter IP address of the 200 series PLC manually. But as this PLC it is available in the same project, we will use the available one. So by default it will select the interface and the IP address and subnet mask. Rest setting we have to keep it as it is, and here there are two areas, address 1 and SD1. So in the address 1, here we have to give the memory area for the remote PLC where we want to write data. So in the remote PLC we want to write a data in DB1, and from first bool, that is DBX 0.0 to the integer 4. So here integer 4 it is available on 24 and 25 bit, 24 and 25 byte. So here total bytes we required 25 bytes, because this 24, so this integer 4 it is available on 24 and 25th byte. So the format will be db1 db sorry it will be p hash db1 dot dbx 0.0, and how many bytes we require? 25 bytes. And in the SD1 we require so here we require the memory area of the local CPU from where we want to share this 25 bytes. So in the local PLC we want to share the data from DB1. Now here the DB address is 1, so that we are using DB1. Let's say if you have DB2, DB3, so you can use that respective DB address. So it is having same, so we simply copy and we paste it in the SD. So like this we can add address 2, address 3, address 4 and SD 2, 3 based on the data sharing area. So now let us come to the 1500. So in the 1500 we have to read the data from 1200. So here we will be using get instructions to read the data from the remote CPU. So here we will select the CPU 1200. So it will be by default it is available, and subnet mask IP address it will be selected by default. So here the remote address we have to enter in the address 1. So here the remote address is db1 up to integer 4, that 25 bytes we will be reading. So here it will be same, and the local address where we want to receive the data, so this address we have to give here. So now almost it is ready. So in the put side, from this PLC we will be writing data, and in the 1500 series we will be reading data by using this get instruction. So we have to give this request bit. So what we will do here we will enable the clock memory, so that we will be having pulse. So pulse is enabled for 1500. So here M0.5, that 1 second pulse we will be using in the receiving, and in the send, for send instructions we will also enable the clock memory bit for the 1200 CPU. So here we will use M0.5 for transmitting and for receiving. So now both the instructions are ready. So what we will do here, we will use simulation to see the data exchange between these two PLC. So here we require one 1200 CPU. So IP address is 1. Network assignment, okay. So 1200 CPU, it is ready. So here we will come back to 1500 CPU where we are reading the data. So one more CPU we require here, which will be having IP address 192.168.0.2. So here we will download this CPU into the PLC sim. So it is, let us see the instructions. Okay, PLC is in run mode and the instruction is executing without any error. So if we have any error, then this error bit it will get on and we can have the status. So at the moment we don't have any error. So let us see in the 1200 series PLC. So for sending also, okay, so this PLC is in stop mode. We will make it on. So this instruction it is executing without any error. So now let us see the data exchange. So we will open the both the DB and so this receive. So this is send DB and here this PLC is in stop mode. Okay. Now if we make the, so this is send DB and this is 1500's receive DB. So here if we make this true, yeah, the bool one it is getting true on the receive. So here we will make true again, true. Here we see the value, it is whatever we are making the modifying the value in the transmitting PLC, the same value it is updating on the receiving PLC. So 3 4 4. So integer also we will change 111 111 222 222 333. So in this way we can send the data from 1200 series PLC and we can receive the data in the 1500 series PLC. So in this way we can use get and put instruction. Now let's say if we want to send the data from 1500 series PLC and we want to read it in the 1200 series PLC. So here what we will do, we will add 1 dB in the 1500 series PLC. So we give the name send db3 and we will add bool1, real 1 and integer 1. So this is only for to check the duplex communication. So at the moment we have tested the simplex communication, that is one-way communication from 1200 series PLC to 1500. So here what we will do, we will send some data from 1500 series PLC and we will read the data in the 1200 series PLC. So same thing, same setting we have to do, we have to enable the, we have to disable the optimized data access. So here we require 7 byte. So as this integer one, it is available on the 6th and 7th byte. So total we require 7 byte. So we will copy same structure, and here we can add receive data from 1500. So it is taken 3rd dB, and same setting we will be doing. We will disable the optimized block address and 7 byte we required here. So now let us see what instructions we will be using. So if we want to send data, so we have to use put instructions. So in the instruction pan, in the communication, we have to use put instruction here. Select the dB here, M0.5, and in the configuration we have to select partner. The local is 1500, so our remote is 1200. So here the remote address is p hash db3 dot dbx 0.0 byte 7. So local address is the db3 dbx 0.0 byte 7. So this instruction is used to send the data from 1500 to the 1200. So now same instruction, get instructions, we have to use in the 1200 CPU to receive the data from 1500. So again M0.5, in the configuration we have to select remote CPU 1500. By default it will take IP address and subnet mask. Here the remote address is db3 dbx 0.0 and byte 7. So now both the instructions are ready. So now what we will do, we will download the changes into the respective CPU, and let us see how data will be transferred from 1500 to 1200 series PLC. So here download 1500 series PLC. So now let us go to the, yes, it is in run mode. So this also we will check. So this thing is also in run mode. So 1500 we will see in the run mode, and we don't have any error in the 1500 and in the 1200 we don't have any error. So now what we will do, so here we will open the send db of 1500. So this is send, and we will open receive db in the 1200. So this is receive db in the 1200, and this is the send db from 1500. Now here what we will do, we will modify the first bool. Yes, it is transferred to the 1200. So 4.17, it is transferred to the 1200 series. So here you can see the 1200 series, and this CPU is 1500. So in the same way, so limit is so here I think we have used 7 byte, we have to use 8 byte. So the integer, it is not transferring one integer. So here we have to use 8 byte, 8 byte, and in the 1500 also we have to use 8 byte. Now let us see the send one. So now if we change it to the, okay, so 256, 256, 555, 555. Okay, so we have to ensure the memory area range. So here the integer 1, it is available on 6th and 7th byte. So from 0 to 7th it will be 8 byte. So that's why we have mentioned here total we required 8 byte. So in this way we can do the PLC to PLC communication in the TI portal. If you like the video, please like, share and subscribe. Thank you.